Hello everyone, welcome back to the Network Fixer, the channel where we simplify networking concepts so that anyone from beginners to experienced network engineers can understand them. Today, we are going to talk about something that every network engineer uses but very few actually understand in depth: logging levels. We will learn what are logging levels, why do we need logging, how logging can actually slow down your devices, what happens if logging isn't configured correctly, what's the difference between logging, Syslog, and NMS. Are logging levels the same on servers, routers, switches, and firewalls? We'll also understand real world production examples, best practices followed by enterprise companies. By the end of this video, you will understand why logging is one of the most important components of network troubleshooting. Let's begin. What is logging? Imagine you are driving a car. Suddenly, the engine stops. You take it to the mechanic. The mechanic asks, when did it happen? Was the engine overheating? Was the battery warning light on? Was there any smoke? Now imagine you have absolutely no idea. The mechanic has almost nothing to work with. That's exactly how IT infrastructure works. Whenever something happens inside a router, switch, firewall, server, or application, the device records the event. This recorded information is called a log. A log is simply a record of everything happening inside the device. Think of it as the device diary. Every second, the device is writing entries like I received a packet, interface gigabit Ethernet 1 went down, VPN tunnel established, user admin logged in, CPU utilization reached 95%, configuration changed. Everything becomes a log. Without logs, you are blind. Why are logs important? Logs help answer questions like why did the internet stop? Who logged into the firewall? When did the VPN disconnect? Why did the server reboot? Why is the switch restarting? Who changed the configuration? Without logs, every troubleshooting session becomes guesswork. This is why experienced engineers always say first check the logs. What are logging levels? Not every event has the same importance. For example, a firewall rebooting unexpectedly is much more serious than a user successfully logging in. That's why operating systems classify logs into different severity levels. These are called logging levels. Think of it like hospital emergencies. Some patients need immediate surgery, others only need regular consultation. Similarly, logs are categorized based on importance. Let's move on to the 8 logging levels. Most networking devices follow the Syslog standard with 8 severity levels. The level 0 or emergency is the first level. This is a situation where the entire device is unusable. Examples include kernel crash, storage failure, system panic, memory corruption, power supply failure. This requires immediate attention. The next one is level 1 or alert. This indicates action must be taken immediately. Examples include primary firewall failed, high availability cluster broken, storage is unavailable, critical database is offline. Let's move on to the level 2 or critical. This indicates a critical hardware or software failure. Examples include VPN service crashed, routing process stopped, switch ASIC failure, firewall daemon crashed. The next one is level 3 or error. It indicates something has failed. Examples include authentication failed, disk write failed, DNS lookup failed, interface errors, packet forwarding failure. The next one is level 4 or warning. This indicates a potential issue. Examples include CPU utilization above 80%, memory reaching threshold, temperature is increasing, packet drops are starting, certificate nearing expiry. The next one is level 5 or notice. These are normal but important events. Examples include configuration change, administrator logged in, interface changed speed, BGP neighbor established, OSPF adjacency formed. The next one is level 6 or informational. These are mainly for general operational messages. Examples include interface up, interface down, VPN connected, DHCP lease assigned, user login successful. The next one is level 7 or debug. This is the most detailed logs. Every internal process is recorded. Developer level information, packet processing, function calls, memory allocation, API responses, internal routing decisions. This level generates enormous amounts of logs. Why is the debug logging dangerous? Many beginners think if I enable debug, I will get more information. That's better. Actually, the answer is no. You should never do that. Imagine your office receptionist writing down every single word spoken by every employee all day. Very quickly, she will spend all her time writing instead of doing her actual job. That's exactly what happens to network devices. The CPU starts spending more time generating logs than forwarding packets. How does logging impact performance? Every logging requires detecting the event, creating the message, timestamping it, allocating the memory, writing to buffer, sending to Syslog server, sometimes even encrypt the connection, sometimes compress, sometimes store on SSD. Every one of these actions consumes CPU, RAM, disk, network bandwidth. If your firewall processes 1 million packets per minute and every packet generates logs, your CPU utilization can jump from 20% to over 90%. Now packet forwarding becomes slow. VPNs disconnect, applications timeout, voice calls break, internet becomes sluggish, not because of traffic, but because of excessive logging. Let's consider an example of a real enterprise. Imagine a FortiGate firewall, everything is working fine. One engineer enables debug logging to troubleshoot one VPN issue. Then, he or she forgets to disable it. The next morning, employees report internet is slow, VPN is disconnecting, iCPU, firewall GUI is not opening. The issue wasn't bandwidth, it wasn't hardware, it was excessive debug logging. This happens more often than people realize. Now let's move on to the buffer overflow. Devices usually have limited log buffers. Suppose your switch can store 10,000 logs, debug logging creates 1 lakh logs every time. Suppose your switch can store 10,000 logs, debug logging creates 1 lakh logs every minute. Older logs get overwritten. Now, when you finally start troubleshooting, the original error has already disappeared. You only see millions of debug entries. The important information is gone. Let's understand the difference between logging, Syslog, and NMS. Many engineers confuse these three terms. Let's simplify them. Logging means generating events inside the device. Router creates logs, firewall creates logs, server creates logs, everything starts here. Syslog is the protocol used to send logs to another machine. Think of it like email. The log is the message, Syslog is the postal service. Instead of storing logs locally, the device forwards them to a centralized Syslog server. Examples include Greylog, rsyslog, syslog-ng, Splunk, Elastic-Stack. The next one is NMS, which stands for Network Management System. Examples include Zabbix, PRTG, SolarWinds, Manage Engine Op Manager, Liber EMS. NMS primarily monitors device health using protocols like SNMP, APIs, ICMP, or agents. It answers questions like: is the device reachable? What's the CPU usage? How much memory is free? How much bandwidth is being used? How many users are connected? An NMS can also ingest its logs, but its primary role is monitoring rather than log storage. So the relationship is from the device it goes to logging, and later with the syslog, and then for syslog server, and device to SNMP or API, and later with NMS. Some platforms combine both monitoring and log analysis, but they are still conceptually different. You might be thinking, is logging the same on servers and switches? The concept is the same, the content is different. A switch logs port up or down, STP changes, MAC learning, VLAN changes, PoE events. A router logs routing updates, BGP neighbors, OSPF events, NAT, VPN. A firewall logs allowed traffic, blocked traffic, IPS detections, malware, VPN, policies. A Windows server logs user login, application crash, Windows update, disk failure, service stopped. An application server logs database queries, API requests, exceptions, authentication. So the logging mechanism is similar, but each device logs events relevant to its role. Let's consider a few of the best practices. In production environments, keep informational or level 6 for routine operational visibility where appropriate. Try to use level 5 or notice and warning or level 4 for important operational events. Always forward logs to a centralized Syslog server. Synchronize device clocks with NTP so timestamps match across systems. Enable level 7 or debug only while actively troubleshooting. Try to disable debug immediately after the issue is identified. Try to rotate and archive logs to prevent storage exhaustion. Try to monitor the CPU, memory, and disk usage on your logging infrastructure itself. Now, let's understand a few of the common mistakes and also try to avoid these pitfalls. Enabling debug on production devices for long periods is a big no. Storing logs only locally is not a best practice. Not monitoring disk space on log servers is a critical piece of maintaining the log server itself. Ignoring time synchronization makes events impossible to correlate. Logging every event without a retention policy is not a good idea. Failing to secure logs, which may contain usernames, IP address, or configuration details, can lead to a big chaos down the road. Let's quickly recap. Logs or records of events generated by devices. Logging levels classify those events based on severity. Excessive logging, especially debug, can consume CPU, memory, storage, and bandwidth, which also degrades the device performance. Syslog is the standard mechanism for transporting logs to a central server. An NMS focuses on monitoring device health and performance, though some NMS platforms can also collect and analyze logs. Whether it's a server, switch, router, or firewall, logging is essential for troubleshooting, security, auditing, and compliance. The key is choosing the right logging level for the situation and avoiding unnecessary verbosity in production. If you found this video helpful, don't forget to hit the like button, share it with your friends, and subscribe to the Network Fixer. If you have questions or topics you would like covered next, leave them in the comments below. Thank you for watching, and I will see you in the next video.